notes for AP Calculus on the topic of derivative rules continued. So it says the table above, well in this case it's not above, but right next to it here, gives selected values for a differentiable and decreasing function g and its derivative, g and g prime, and let f be the function with f of 3 is 2 and the derivative given by f prime of x is x cosine of e to the x. And we want to find f double prime of the sine of 2 for part A. All right. So we've got two different functions here, one with the equation, one within the table here. So f double prime of sine of 2, well, before we can find out, we need to find f double prime of x. So using our f prime of x function here, notice we've got x times cosine of e to the x. So overall, that's a product rule problem. And we're taking the derivative of that to get the second derivative. And notice we've also got e to the x inside of cosine, so there's a chain rule within it as well. All right, so let's find f double prime. Okay, so using the product rule overall, the derivative of the first one, derivative of x, is just 1 times the second one as it is, cosine of e to the x, plus the first one as it is x, times the derivative of the second one, derivative of cosine. Remember, the trig functions to start with, so you have derivatives that are negative. So it'd be negative sine of e to the x. And then using the chain rule times the derivative of e to the x, that's the one that the same is just e to the x. Okay. We can simplify this a little bit here. So we have cosine of e to the x. And bring this negative out in front. You can leave the x out in front. E to the x times the sine of the x. Now here, sine of 2, now this is not an angle that we know off the top of it. You could punch in your calculator to get exactly what it is. But in this case, it just represents some constant that we don't know the exact value of right now. So substitute in, it may look a little weird, but it would be cosine of e to the sine of 2 minus the sine of 2 we get substituted in there for x times e to the sine of 2 and then times the sine of e to the sine of 2. So just like any other constant we're substituting, we're just substituting for all the x's. And so where does that look? So that would be our answer there. All right, let's look at this next one. Now it gives us another function h, and h is defined by g of f of 2x, find h prime of 1.5. So to find h prime, the first derivative, notice here, we've got g on the outside, f inside that, and 2x inside that. So this is a chain rule problem and actually a double chain rule, because there's two functions. Remember, you start on the outside and work your way in. So start on the outside, the derivative of g, we don't know what the function is, we would just write as g prime. And then the function inside, f of 2x, stays the same. Then we take the derivative, the next function inside f, we would just write as f prime. The function inside 2x stays the same. And then we have the derivative of the innermost function, derivative of 2x is 2. Okay, not really much that simplifies here. I guess you could bring the 2 out in front. But let's go ahead and substitute in 1.5 now. I'll just bring this 2 out in front, a little simpler. And then we'll have g prime of f of, well, 2 times 1.5 is 3. 3. And then f prime of, again, 2 times 1.5 is 3. And let's keep simplifying. So h prime of 1.5 got 2 times g prime of f of 3 they give you right here is 2. And f prime of 3, well, we have f prime of x, so we can figure that out off to the side using the function they give us right here. So f prime of 3 would equal 3 right here times cosine of e to the third. So that's what we'll put in right here. 3 cosine e to the third. And then g prime of 2, notice from the table, there's 2g prime negative 3 right there. So we can put a negative 3 right there and get our final answer for h prime of 1.5. So we'll have 2 times negative 3 is negative 6 times 3, negative 18 out in front. And then we still have cosine of e cubed. That would be our answer for part B for h prime of 1.5. Again, it's just a constant, just like part A. It just looks a little weird because we get cosine of e cubed, but that's just a constant. All right, so that's the one with you call it a tabular problem, partly anyway, because when you're looking at a table of values there. All right, then for part of the next problem, take a look at that. Here we're given this function f of x is ax plus b over x squared minus c. It has the following properties. It's an even function. The limit as x approaches 2 from the right is infinity, and f prime of 1 is negative 2. Determine the values of a, b, and c. So you have to figure out what those constants a, b, and c are. All right, so let's remember the fact that it's even. Remember that means it's symmetrical about the y-axis. Remember the way you test for y-axis symmetry is with an equation, since we don't have the graph of it exactly, is you substitute in negative x for x. So this would be a times negative x b over negative x squared minus c. And in order for it to be even, to be symmetrical with the y-axis, it has to give you an expression that's the same, equivalent to the original f of x. So if we simplify this, we get negative ax plus b over the negative squared the negative goes away when you square it. But if you look at this, it's not the same as the original, because notice this has got a negative here, a of x, and this is a positive a of x. But we know it has to be even, right? It tells us it has the following property. But we just showed these are not the same. So how can we make these the same? Well, we're trying to find the values of a, b, and c. Well, let's think, what's the only value of a that would make these two equivalent? Well, if a is 1, it'd be x and negative x. Those aren't the same. A is 2, 2x and negative 2x. The only thing that would make it the same is if a is 0, because then it would wipe out this x term altogether. So then both expressions, a is 0, this would be b over x squared minus c and b over x squared minus c. So based on that first property, we know a has to be equal to b. All right, next let's take a look at the limit as x approaches 2 from the right is infinity. Well, if you have an infinite limit as x approaches a specific value, infinity or negative infinity, the only way that can happen graphically is if you have a vertical asymptote. So this is telling us we've got some vertical asymptote right at x equals 2, and from the right it's going up to infinity like that. All right, well, the only way we can have a vertical asymptote there is if the denominator is 0 when x equals 2. Let's give you some number over 0. So if we look at our denominator, x squared minus c, when we plug in 2 there for x, 2 squared minus c, that has to equal 0. So that would give you 4 minus c equals 0, and then add the c over. So c would have to equal 4. All right, so we found the value of a, now we found the value of c. And the final one is to find f prime of, well, use the property that f prime of 1 is negative 2, and that should allow us to figure out the final value of what b has to equal. All right, so remember, we already figured out in part, based on the first property, that a is 0, so now we can think of f of x. Just b on the numerator, which is that's all that's left. And now we know c is 4, so divided by x squared minus. So the only way we can utilize this f of 1 is negative 2 is if we actually find the derivative. So f prime of x. And notice here we'd be using the quotient rule. So use the quotient rule here. The derivative of b, remember b is a constant we're trying to solve for. The derivative of constant all by itself is 0 times the denominator as it is. That is 0 there. And remember on the quotient rule it's minus the numerator as it is times the denominator. So the denominator is 2x, all divided by the denominator squared. So the 0 wipes out this term entirely. F prime of x. All that's left on the numerator, it would be negative 2bx on the numerator. And x squared. You could square it out, but I don't think it's going to be helpful in this case. Times 4 squared. So let's utilize this point now. We know when you plug in negative 1, our derivative should equal, so plug in positive 1, our derivative should equal negative. And then the derivative should equal negative 2 when we substitute in 1 for x. So negative 2 times b times 1 divided by 1 squared minus 4 squared. We get negative 2 equals, that's negative 2b on the numerator, divided by, let's see, that's 1 minus 4, that's a negative 3 squared is 9 on the denominator. And then just solve it for b. So you can multiply both sides by 9 to wipe out the fraction. Give you negative 18 equals negative 2b. And divide by the negative 2. So we get b would have to equal positive 9. Alright, and you can just test it out real quick to see here. If we made b 9 here, and you plugged in 1, you get 9. See if that work. So we have 9 for b. Then when you plug in 1, oh no, that's the original function, sorry. You're looking at the derivative. If we plug in 9 for b, that'd be negative 18. And then plug in 1 for x, that'd be negative 3 squared. So negative 18 divided by 9 would give you negative 2. So just check on it. Let's take a look at the next one. So we're given the graph of g, and it's just a piecewise linear function, 2 pieces. We can see a couple points on that. And it says f is given by f, g of x, so a function inside itself. What is f prime of 0? Well, before we can utilize f prime of 0, we need f prime, right? F prime of x. Notice we've got g of x. So this is a chain rule one. Start on the outside with the one g in red there. So it'd be g prime, and the function inside g of x stays the same, times the derivative of the inside function of g of x would be g prime. And then we can substitute in 0. That's what our objective is, to find f prime of 0. So it'd be g prime of g of 0 times, and now is when we have to use the graph, because we have the graph of g. So let's start with g of 0. Well, g of 0, that just represents the y coordinate. You can see right here, got a y coordinate of 3, so g of 0 is 3, so we'll start with that. So the f prime of 0 g prime, g of 0 we just figured out is 3, times, well, g prime of 0, this is the derivative, which remember represents the slope. In this case, the slope at x equals 0. So we're looking at the slope at this point, not the y coordinate. Let's look at the slope. You can find the difference between these two. We got these 2 points, right? The difference of the y is 5 minus negative 1 over the difference of the x is 1 minus negative 1. So you get 6 over 3. You can see that if you look at it carefully, it does go up 2, right 1. So the slope is 2 there. And then same thing right here, g prime of 3, right here at 3, doesn't represent the y coordinate, it represents the slope right there. So this is the slope at x equals 3, which we can figure out here. This is the point 6, 0 goes through. So again, difference of the y's, so 5 minus 0 over the difference of the x's, 1 minus 6, 5 over negative 5. So f prime of 0, so that's a negative 1. So negative 1 times 2, so negative. Take a look at one more here. So it says if f and g are twice differentiable functions, such that g is e to the f of x and g double prime is h of x e to the f of x, then what is h of x equal? Okay. So kind of hard to see maybe how to go about solving for h of x here. But we have g of x, and h of x is in the second derivative. So let's just go from here and find the second derivative. So g of x, the g prime of x, first derivative first. Notice it's just a chain rule one. We've got e here, and inside that we've got f of x as our function, the exponent. So that's the chain rule. So the e part would stay the same. E to the f of x. The chain rule says we have to multiply by the derivative of the inside function. Derivative of f of x is f prime of x. So that'd be our first derivative. And then to find the second derivative, g double prime of x. What we're given here, but let's find what it would have to equal based on what g of x is. Notice here we'd have to use the product rule. Okay, and so then we have the derivative of the first one. Again, using the chain rule would be e to the f of x as it is, times the derivative of f of x, f prime of x. Derivative of the first one times the second one as it is, x, plus the first one as it is, e to the f of x, times the derivative of the second one, derivative f prime would be f double prime. Okay. So then we've got a GCF. We want to figure out what h of x is. And notice we've got e to the f of x here times it. So, okay, so now what we can do, notice, is factor out. There's a GCF. They both have e to the f of x here. So we can take that out as a GCF. And then notice what we're left with is f prime of x times f prime of x. You can write that if you want it. F prime of x squared, and then plus f double prime of x. So notice we're told g times double prime equals, we bring this expression down, we're told it equals, I'll just flip the terms around, but we're told it equals e to the f of x times h of x, what we're looking for. And here's the e to the f of x, so notice because of this format here, f of h of x would have to equal this same expression here. Okay. So we know h of x is f of x squared plus f double prime of x. And that concludes the notes for AP Calculus on the topic of derivative rules continued.